Good morning, ladies and gentlemen. I'm going to introduce to you Data Slicer, which is done as part of a final year project by myself, Paul Anthony, and my colleagues Mohammad Sishan, Sraya Kulangira, and Sakriya Joshi. Let's begin. What is Data Slicer? Machine learning has become prevalent in our day to day lives. It is used in fields like finance, manufacturing, healthcare, and so on. Analyzing and improving the performance of machine learning models can create a huge impact in these domains. Data Slicer helps find problematic subsets of data that are affecting the performance of machine learning models. Addressing these problematic subsets can help improve model performance. Problems addressed by Data Slicer: tracking the problem of ML models back to the underlying data and finding subsets or slices of data where the model underperforms. Finding slices in the training data which influence the decision making of misclassified data points. Automating the process of defining and evaluating through all possible slices. Rather than arbitrary subsets like x1, x2 till xn, defining them as an interpretable subset like gender equal to male, salary greater than 20,000, and so on, can help improve model debugging. Providing a visualization based interface where users can visually analyze the slices. It is not constrained to a specific type of model architecture like naive Bayes, support vector mechanism, neural networks, and so on, but works for all models. Let's learn more about Data Slicer using a demonstration. Data Slicer is implemented using a web-based view. What you're seeing right now is the home page of Data Slicer. We can select the number of slices k, which I'm giving as 5. We can select the model which we want, which is logistic regression at the moment, and also select the data file, which I'm selecting adult.csv. Now, let's submit this data. Data Slicer takes some time to process through all this data and find problematic slices. So, using the magic of editing, we're going to skip some time. After processing and finding out k problematic slices, Data Slicer represents all the k slices over here. As we have selected 5, we have 5 problematic slices. Each slice is represented using its description, the number of data points in them, and also an error graph, which is the violin graph showing the error distribution for each slice. Now, if we scroll down, we can see the IPALM error wheel. So, Data Slicer uses two techniques. One is Slice Finder, and the other is known as IPALM. In the IPALM technique, we are finding slices in the training data. So, whenever a point is misclassified by the model, the point can be mapped back to a training slice, which influence the decision making of the model to create that misclassified decision. So, what we're seeing here is an IPALM error wheel donut graph. Each section represents the number of misclassified points that are mapped to these sets. So, as you can see, slice number 4 has the most number of error points mapped to them, or misclassified points mapped to them. In the slice finder technique, these slices are made in either the validation or the test data. We can further inspect these slices by clicking on them. What you're seeing right now is a detailed description of each slices. We can see the slice description, the number of elements in the slice, and a violin graph showing the error distribution. In this violin graph, if the bulges are towards the left, which is good as it represents that a large number of small errors are occurring. If the bulges are towards the right, it's bad because a large number of large errors are occurring for the model in this given data slice. Also, we're showing a confusion matrix heat map, and also the accuracy, precision, recall, and F1 score for the model on this slice of data is shown here. Using the information we get from a data slicer, like the problematic slices, their distribution, and so on, we can create solutions by modifying the underlying data so that the model's performance increases. I believe that you have understood how Data Slicer works, so see you later. Goodbye.